In this video, we will learn about two important special methods that we use a lot in practice, the sorting and the reversing. There is what we call an algorithm. You should study the algorithms course after programming course. And the word algorithm is a step-by-step procedure for calculating something. Already during the loop section, we were exposed to a lot of problems that involved several iterations. We call these problems computational problems. They involve a lot of steps, and this kind of problems can be very inefficient, affecting your application. And here is why the algorithms field come to try to find an efficient answer for a solution. One of such algorithms is what we call sort algorithm. Sorting algorithms just order the items in your list by default from small to large. And one type of algorithms is what we call in-place algorithm. In-place algorithms mean it's going to change the list itself instead of creating a new list. So it is in-place modification within the algorithm itself, the model, the data itself. It might definitely create some very minor data, but the moral of it, if you say you have a list of 1 million items, it is going to change the list of 1 million item itself, not creating a new 1 million item list to do something. Let's say some code. If you defined a list here 572, then you can call the method list.sort. List.sort doesn't return something. As you see here, I'm not writing list equal list.sort. I'm just saying a list.sort. The reason behind that, the sort is in place algorithm, so the list itself will be changed. If you try to print the list here, it will be 257. If you want the list to be sorted or ordered from large to small, you can write here argument reverse equal true to get 752. As we learned, it's a common mistake to write list equal list.source. The list will be none. So you have always to be careful about your functions. Does this function return something or not? Is it in place or not? There is also another function that's called sorted. This is a function. This isn't a method. So the sorted function can take anything that is iterable. Iterables mean it is a sequence. It's something that we can iterate over it. We know so far that the list is sequence and iterable. The string is a sequence. It is iterable. When we call the sorted function isn't in place. The sorted function will return a copy for you. Now here is a list, and you call sorted over list to get a new copy. The list will not be changed. It will remain 572, but the list sorted one will be 257. The moral of that is two things. The first, do you really want to change your list itself or get a new copy of it? Do you want the sorted to be internally here or something new? You have to decide which one you are going to use. If it is you would like to just change the current content, you just call list.sort. If you would like to get a new thing, you call sorted method. As I said, sorted is more general. It can take a sequence like a string. If you try to sort this string, you will get a list of sorted items. Notice, because this is a bit counterintuitive, you would feel I'm giving it a string, it will return a string, it will actually return for you a list. In a similar way, you can write reverse equal true to get them reversed. A common mistake is to name your returned item sorted. Remember, if you have a sorted function and sorted, you cannot use the sorted anymore. So the word sorted is preferred to avoid it as your variable name. On the other side, we have the reverse method and reverse function, which is doing the same thing. If you have here my list and you call .reverse over it, you will get the reverse of this list. Let's say you can append more items. But now if you decided here to reverse it over my list, then notice here, this is also one difference. The reverse it over my list doesn't return a reversed list. It returns something we call iterator. Remember, in the class homework, we take a class that can return has next and get next. This is very similar to the iterator idea. What we call at this time in the homework my range. So this is actually an iterator. It is something that we can use to iterate over something. If you would like really to get a list, you can say something list over reversed of my list. Now you are going really to get a new copy of this list, but now reverse it. So reverse it itself return an iterator, but list of reversed will return you something. This is very similar, remember, to the enumerate. Enumerate doesn't return for you something that you can print directly. You have to iterate over it or use the list of enumerate of something. There is also the .copy function. So you can, let's say you would like to use the internal reverse. You can get a copy and then .reverse it. But this is like, it seems for me ridiculous. Maybe the best one is just this one line of code here. So this is about the reverse method and the reverse function. Maybe a relevant concern now would be how can I iterate over a list in a reversed order? And this is an interesting question. So there are a few ways to do that. The first one is to think like a C++ Java guy. Let's just iterate over length, access the last element one by one. So I'm here iterating on the length of the list, and then I'm computing the last position in the array. I'm computing the length of the list minus position minus 1. Let's trace. Here is the list length is 2, 4. So we are going to iterate 4 items. In iteration 0, we have position with value 0. 4 minus 0 is 4. Minus 1 is 3. So the reason of this minus 1 is to like shift the indexing to be 0 based. So in the first iteration, it will be at 3, then 2, then 1, then 0. This is very C++ style. It is okay, but not the best thing. A better one is the more Pythonic way is to use a range that is starting from the back with a decreasing step. To do that, you can write length of list minus 1 and minus 1 and minus 1. Remember, this minus 1 is a destination exclusive, and this minus 1 is a step. So length of list minus 1 is starting at 3, and then your end destination is minus 1. So you are going to stop at the 0 actually, and minus 1 is a step by step. For some people, this like a weird syntax. This 3 minus 1 minus 1 minus 1. There is another way here. You can remember the reversed function return for us an iterator, so we can iterate over it. So I can say for item in this iterator, keep printing things. One problem with that style is you cannot access the index. In these two guys, we have the advantage of having the index. So one way to do that is to use the enumerate. So here is one way. We can say enumerate over a list. This one will not return an actual list. So we can write a list over this enumerate. Now we have list of items that each item is a start, is index and value. And then we call reverse it over it. We get an iterator, and then we are iterating over it. However, there is one important disadvantage here. When we say list of something, this will create an actual list. So now we will have two lists in the memory. So the disadvantage of this approach, it takes a new memory, but this two here, or this first three, doesn't create a new memory. Including this reversed one, it doesn't create new memory. I mean by that, it doesn't create a new list in the memory. So I believe that one of these three styles may be the best way, and I believe that this one is much better one. It gives us the start and end. It gives us the index, and it's still more Pythonic style. That's all.